Alright guys, today we are solving an investment optimization problem using GAMS. An investor has 30,000 euros to invest in 6 mutual funds. Each fund has a type that can be a bond, a balanced, or equity, a unit cost, and an annual return rate. Our goal is to decide how much to invest in each fund, respect the minimum and maximum conditions on fund types, and maximize the total annual return. About the data, we need to check that the bond funds F1 4.5 euro with 7%, F2 with 4 euro and 88%. Balance fund, we have F3 with 3 euro, 6%. F4 4.5 euro, 9%, and F5 with 5 euro, 9%, with an equity fund of F6, 5.5 euro, and 12%. The constraint is that at least 80,000 euros in bonds fund, at least 12,000 euros in balance funds, and at most 5,000 euros in equity funds. So the total budget is across 30,000 euros. In GAMS, the first step is to define sets. So we are going to define the funds by type. So we have FOB, that are the bond funds, the F-bill balance funds, and then we have the F-ATS with equity funds. About the parameters, we define these parameters that are the unit cost and the return rate. And as last, we define all the scalar that are the total budget, the minimum inbounds, the minimum inbounds funds, and the maximum in equity funds. In the end, we decide the decision variables, that in this case is the number of stocks to buy of fund F, and the objective function that instead is zeta, represent the total annual return. Our objective is to maximize the annual return. About equation, as we have said, the objective is to find the maximization of the annual rate. So we have an objective, and this objective is the sum of every specific rate of return in each part. Then we have a budget constraints that represent the total spending that cannot exceed 30,000. Then we have a bond constraints where at least 80,000 in bonds must be spent. And then we have a balance constraints where at least 12,000 euro must be spent in the balance funds. And the last one is the equity constraints, where at most 5,000 must be spent in equity fund. And that's right here. In this way, we have defined a linear program because all variables are continuous and we are maximizing return. So we write LP, linear programming, because the program is all about continuous variables. And that's the end of our exercise. Thank you for watching. See you in the next video.